Welcome to today's webinar. The topic today is most frequently asked questions answered by Dlubal support team. In this regularly short webinar, we answer questions that our users asked the last time. My name is Andreas Hörold. I'm responsible for marketing and PR in the company Dlubal Software. For instance, technical contents of the website, newsletters, customer projects, the German and English webinars, and so on. I will be the moderator today, and I will also be a presenter. I present the first part of the webinar. Then follows my colleague, Stefan Hoffmann. Stefan Hoffmann is the head of our customer support. He selected the questions and prepared them. And now we will answer the questions. How you can ask questions, I show that on that slide. At first, I switch off my camera that you can see the full screen. You can press that button with the question mark, then enter your question in that field, press send, and we will receive your question and we will answer you. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. Okay, then I open RFEM, and the first question is, I add new objects to the design. Do all results have to be recalculated? The answer is no. It's not necessary to recalculate all. How to do that? I will show that on that simple example. That example, you can find it in the Dlubal Center under examples, then steel structures, and that's the example. I prepared that. I selected also the steel design. Okay. So let's do a steel design. And I select only the member sets. The member sets are all columns. Let's calculate all. I have to mention that I don't edit imperfections. I don't edit buckling lengths and so on. That's why we don't do any stability design here. It's only an example. So I switch to the wireframe model. And you can see we see all the results for the member sets. So, and when we want to design also the members, I select the members, then all results are deleted. So now I show you the other way. I calculate the member sets again. And if you don't want to delete the existing results, go to the navigator data, left at the bottom, and then right-click to steel design and press settings. The other way is to go to the table steel design, input data, and then you can press that button. That's a different way. So, and then you can deselect that button, delete all add-on results by changing input data. And if you uncheck that, the results aren't deleted. So, okay. So now we select also the members. The results aren't deleted, and I can recalculate all. So now we have results for all. It shouldn't be necessary for that simple calculation, but if you have, for example, more complex models or more load combinations and so on, then you can do that, or you have activated the add-on steel design. In this example, only one of two nodes are designed. Yeah, only this node. I can show that. So yeah, this connection or the joint is already calculated, but not this one. And if I deselect that also, okay, then I can press that button for designing the node 5, and the results aren't deleted. It's only an error, not calculated yet, but the results of this node, node 33, aren't deleted. Okay, then we turn to the next question. I want to edit a multi-print afterwards. How do I do that? I prepared for this example. At first, I don't show the results. So as I said, I prepared user-defined views for the frames and rows. And I want to print the internal forces, for example, for the rows or the frames. Let me show that. For example, we showed the member internal forces for N or Y. And we would like to do a multi-print. So let's do that. Print graphics to printout report. Then I select multi-print and window filling. So then we have to select what we want in the multi-print. No views, no loads, but results. For the frames and the rows, user-defined views, then members, internal forces, for example, N, V, Z, and MY. 9 graphics are not the current view. 6 graphics. You can see that in the print in the preview. So those are frames and the rows. Okay, I press save and show that we printed in the printout report. I don't print the steel design results and the steel joint design results. Okay. So now we can see the different graphics. I can change the view, fit page. So those are the 6 graphics, and we want to edit these multi-print. So how to do that? That button, edit multi-print. I select it. Okay. So, and now we can change the settings. For example, results, we want to add the other internal forces. So now we have got 12 images. So, and we can go to or turn to image actions. And we can increase the window. We can say update or no action, add for the new graphics, or what you want. You can also change the graphic, for example, the color grayscale, then all images should be in gray. Update add, we'll leave that. Press OK. So, yeah, the graphics are updated now, all in gray, and we have got all the 12 graphics. Okay, that should be all to that question. The next question is, why do I get a different section moduli in RSECTION than in ShapeFin? Let's turn back to the PowerPoint. Yeah, the reason for that is the determination of the section moduli. That's different in ShapeFin and in RSECTION. For example, in ShapeFin and ShapeMassive, the section moduli is determined by that simple formula. The section moduli is equal then area moment of inertia divided by the edge distances. And in RSECTION, there's a more complex or more detailed formula. It's more exact, and it's an improvement in RSECTION. And you will get different results. And what is important in ShapeFin with the section moduli calculate in this way, it's not possible to directly calculate the maximum and minimum normal stress from the bending moments for asymmetric cross sections. For symmetric cross sections, you will get the same results in both. And in RSECTION, the section moduli are determined in such a way that they follow for the direct calculation of the extreme normal stresses from the bending moments. And that's the difference. That's a short overview. You can find more information in that FAQ. Just press that link. You can download the PowerPoint slide from the event website, where you can also find the recording later and the models. In the next days, you will get an email with a link to that page. Okay, let's turn to our section and ShapeFin. There's an L profile, and let's check the results. The section moduli is the same. We start with the moments of inertia. That's the same. 515.9, and I set is 94.46 for both. But the section moduli is different. So, for example, WY max 75 and where is it? Here, 37.18. The section moduli are different, and the reason is, as I described it in the PowerPoint. Okay, that should be all from my side. I hand over to Stefan. Stefan, it's your turn.
Thank you, Andreas, for handing over. I will continue with the next topic. So the next question is, can the longitudinal reinforcement of members be determined automatically? So I've created a model for you. This is a reinforced concrete building with members building a frame, having 3 frames in a row and 2 stories and load transfer surfaces, which will hand over the imposed load and the snow loads and the wind loads on our building. So we already have static analysis results. And what we now want to show is how you can define reinforcements and let them be calculated automatically for you. So we show it in two member representatives. So number 2 are the outside members and representative number 3 are the inside members. And if you double click on the member representative, you can assign longitudinal reinforcement for all the members in behind. So usually you can define the number of bars and the diameter, but the program can also automatically determine this for you. So not both simultaneously, but either this number of bars or either the diameters. For the representative number 2, we want to automatically design the diameter. So we want to put inside 5 members in the range of 10 up to 20 millimeters of size. So whenever it reaches the maximum, it stops, of course, to input more members or thicker diameter. So you should see in the results that then the design is not fulfilled. So you can later on adjust, of course, these boundaries in order to let the program fully determine the amount of members. So you see what you can enter in here. And for the representative number 3, we want to adjust the numbers. So we hit auto, and then we can also determine with a diameter of 20 millimeters in our example a maximum amount. I know that 4 are not sufficient, so we will try to put in 4 and see what the program will offer us. We go into the concrete design where we now only want to get results of both representatives. So now we hit calculate. Due to the fact that we already have static analysis results, it quickly jumps into the concrete design, now doing the workflow for you. So it's calculating the amount and the diameters depending on what ranges we input. And once we receive results, we can see that one check is not fulfilled. So this may be an information that it's not sufficient reinforcement put inside. So we can quickly determine, of course, for example, the bottom reinforcement for our representatives is like 17 in the middle. And what the program provided us is, if you only check for bottom, 12.57 in the middle. So you may be wondering, of course, why it's not enough. You can also check this in the not covered reinforcement if you want to see the gap. So we can now see that there is only a lag in here. And if you remember, going into the representative number 3, I told that we want, of course, to achieve this result, that we put maximum 4 diameter 20 inside, which will give us 12.57. So this is, of course, not enough. So in order to let the program run in the full capacities, we now allow that we want to have maximum of 8 members in this member representatives. So there is no boundary for the program that it has to stop. It can now determine and fulfill the design process. So whenever you get then results, we see that in the table there is no limit anymore. There is of course a maximum, but this is only due to constructions. And if you now compare once again, it does not change. We need 1712. And we provide now 1885 in this area. So this means that there is a no not covered reinforcement for our model. And this shows how you can quickly automatically let the program determine the required reinforcement for your members. We will go to the next model, our block foundation. So the question is, can I design a block foundation in RFEM 6? And yes, it's possible. So quickly about the model, we have just a single column which is fixed at the bottom with some loads on it. And in order to define a block foundation, you have to assign it in a nodal support. So you simply hit the check that it's a foundation, and then there's a next topic where you can choose what foundation you would like to choose. So it's object orientated, as RFEM 6 offers you, to define one object of a block foundation for multiple columns. And you just simply need to assign this object then, and you do not need to type in multiple inputs just for multiple similar objects. So once you define this, it is also shown graphically, and if you double click on it, you directly jump into the single foundation. And you can see that there are several types, and we want to take care of the block foundation with smooth bucket sides. So first you need to start with a material of the plate, what you define, and then you can step into the geometry, where you can also define then, of course, geometry by checking the sketch, or you simply switch into the full view, where you can also use the view cube in order to rotate your model to see if it fits for your column and your purpose. And then you step in the next reinforcement definition, where you choose the material and the types. Then you switch into the cover, so you can define different durabilities for different places. And the next definition would be the plate reinforcement, so the bottom and top ones, where you can enter the data you would like to do. So you can also directly see the representation of the concrete reinforcement in the graphics. You can also jump with this shortcut into the reinforcement layout, where you also have the view cube, and you are able to switch on and off some certain reinforcement types and also to print it into the protocol. The next one is the block reinforcement. So for the bucket sides, you can also define then stir-ups, which is most likely necessary depending if you have a lot of horizontal loads. The next one would be soil properties. So we also would like to do a geotechnical analysis in our model. So you can define user-defined soil parameters, or most likely with the geotechnical add-on also a soil massive, in order to gain all the soil properties what we need. The last two steps would be to check or assign geotechnical design configurations, where you can choose what you would like to inspect. So either it's necessary to do all, or you can just choose to do some designs only. And last but not least, of course, the concrete configuration, where you are able to adjust the current set parameters. So we defined all the properties. We just step quickly once again into the loads. So we defined multiple design situations. So the normal ultimate limit design with structural and geo collapse, the other SLS situations, and also a ULS equivalent permanent and transient design situation, what we will only take care about in our concrete foundations. So jumping into the concrete foundations, you see that we have assigned the design site types, and if we hit calculate, it will run first of all the static analysis, because we do not have results yet in this file. Does not take long. You can see 6 cores are used on my computer, 3 seconds. And then we will directly jump into the results. So you have, as you are maybe used to, also table results, where you can switch between representation of different information. And you can also use, of course, the navigator in order to check for all the required or provided reinforcement, which is split as shown in the first part, also for the plate, bottom and top, and also for the block reinforcement, what might be required in order to fulfill the force distribution into the foundation. And of course, you can once again also see then the not covered reinforcement by checking the values. So as you can see, we are lacking some reinforcement in the bucket sides. So we are coming to my last example. And the question is, how can I create moving loads in RFEM 6? So in this example, I use the model from our knowledge base article 1908. So we have a load what we would like to define, 2 single loads, 1.5 meter spacing, vertically and horizontally in both directions. And we have then an axle load of 240 kilonewton per square meter with a size what is given in here. So it should go across the bridge. In order to have the loadings to be defined, we first of all need to have a line, which then needs to be a line set. So the line set will be used in order to define the load direction. And then it's no extra add-on what you need. It's already included into the main program. So it's a load wizard where you define a new load wizard with the moving loads. You first of all go from top to bottom, left to right, and you have to design or define what surfaces you would like to use. In our example, we can hit all because only our street is used with surfaces. And since we only have one line set, it's already assigned on over here. And we want to have the moving step a 1/4 meter. And the rest we can use as it is given, only one lane. And the next thing would be that we have to assign our lane definition with our load model. So you can go in over here, click there, since we did not yet define a load model. And we want to use one load component with a force, load direction ZL. We want to use the axle free rectangular load. And we will start at 0, have a gauge of 1.5. 240 as tall, and then the width and the length, 1/4 meter. And if we hit OK, the lane and the load model are together, and we only need to hit OK. So you can see that loads will be created, 81 load steps. And you can then, of course, see how the load is moving on over your bridge by checking these steps. You can also run a calculation if you would like to do so for one certain load case, or you use it in a result combination that you can get knowledge about the overview of your results. And also a good step you could use is the distribution of loads, where you can check how the loads will be transferred, most likely on PZ values, or sometimes also as split nodal loads, depending on how you use the definition. All right, so I come to an end. Thanks for your attendance, and I hand over back to Andreas.
Thank you, Stefan, for your nice presentation. I have an additional hint for you. You can book our online courses, for example, the RFEM 6 Masterclass course for beginners, then the Eurocode 2 course or Eurocode 3 course. You can get more information when you press the buttons, the button on the bottom, or you can scan the QR code. As I said, more information and the prices. Just take a look. Okay, that should be also all from my side. I thank you for your attention. Thanks to Stefan for your part of the presentation and for preparing the questions. I wish all a nice rest of the day. Bye-bye.